So the California Energy Commission did a couple of years worth of work, and Gary was one of the leaders of that project, and they came up with some really very interesting numbers, that almost 20%, 19% of their electric energy load was related to the movement, treatment, and disposal of water in California. That's including the consumer's end use. So when you add in the end uses by the consumer, that number is very, very high. 32% of their gas load was related to the heating of hot water. So it seemed intuitively obvious that if you then could conserve water, you would be conserving energy, and that is a very important connection to make for the energy efficiency community. And the Energy Commission went even further, and they said, well, let's take a look at what would be really cost-effective programs. We've done so much energy efficiency program work, we don't have the same kind of low-hanging fruit that they have in the water efficiency world. What if we were to consider taking all of our energy efficiency money, and I think it's something like $500 million a year, and put it into water efficiency programs? What would that look like? And the Energy Commission concluded that they could get 95% of their 3-year energy efficiency goal with funding water efficiency programs at only 58% of the cost that they currently pay. So it's a good energy efficiency investment. That's the bottom line. Water efficiency is a good energy efficiency investment. And those kinds of numbers, I think, are very useful. Even though it's California and water has moved great distances in California, you net out that long distance movement, it's still a sizable amount of energy benefit that can be gotten from water efficiency programs. At the individual city level, it has an impact. 33% of a city's municipal budget can be for water pumping, their electric bill, that is. 33% of their electric bill can be just for water pumping. 34% of a water utility's O&M operations and maintenance budget often goes to energy because of the intensity of the treatment process. So all around, it's beneficial for the ratepayer, for the taxpayer, for the utility manager to look at water efficiency as an energy efficiency opportunity, because not only does it save energy, but it saves greenhouse gas emissions. And there has been a model developed that will quantify that for any water system. And this is the Pacific Institute, again, getting involved in putting together a model for agricultural and urban water utilities who can take a look at their system operations and take a look at their water supply parameters and figure out how much embedded energy there is in their own water supply, and therefore in their water conservation programs should they undertake them, and compare it to their overall carbon footprint. So this model was developed by Gary Wolf at the Pacific Institute. I think it probably got some Energy Commission support and funding. And now I know the Energy Foundation is looking at doing some further refinements to it, so there'll be new versions of it coming out that utilities around the country will be able to use. And so that work is underway, but you can go to the Pacific Institute website and you can download this model. Just hackinst.org, and you type in the search bar, you just type in water to air model, and it'll pull up the page with the water and energy models for both the urban and agricultural water utilities. So one particular water utility in California took that model and decided to test it, to do a little run through it. And Santa Clara Valley Water District, which is the water district, the wholesale water district that services the San Jose, Silicon Valley area, they did an analysis of their operations, and they published a report called From Watts to Water. We have a couple of copies sitting there on the table. We also have the PDF of the report posted on our website, and I can email it to you if you give me your card. But this is a terrific report because it is the first published example that I'm aware of a water utility taking a comprehensive look at what their embedded energy values are, and at what the benefits are of water efficiency technology to those analyses. So, for example, the clothes washer, they calculated in their particular program that they were basically saving over 9,000 kilowatt hours per washer over a 12-year lifespan of the washer. And they were conservative. They gave the washer only a 12-year lifespan, which I think we know is probably pretty conservative. And in that 12-year lifespan, they calculated that it saved over 2,000 kilograms of carbon dioxide per washer over that period. And so if you aggregate all of their clothes washer examples, and you take all of their conservation programs that they've been undertaking since they started in, I believe it's 1992, the total energy savings that they've basically incurred in that program is equivalent to the energy that would be used by 236,000 households for 1 year. So that's water efficiency, that embedded energy translated into a direct energy savings that we had never really thought about before. And if you go further and you take that and convert that into greenhouse gas emission reductions, it ends up being equivalent in terms of carbon reductions to removing 82,000 passenger cars off of the road for a year. So this is a whole new benefit calculation that should help galvanize water efficiency efforts in water utilities, because not only do they have water scarcity issues to deal with, but they have energy scarcity issues and costs to deal with, which are often much higher than their supply costs are. And saving energy is an important benefit in their operations. What are those opportunities? Well, of course, the energy benefit is higher if you're saving hot water, but it's also pretty good depending upon where you're located if you're saving cold water, like my Lake Arrowhead example. But the technologies that we're looking at here for joint water and energy programs are clothes washers, commercial 1.6 gallon per flush and lower toilets, because those toilets are flushed so much in the application workplace. Landscape conservation, even though it's cold water, so much landscape water is applied that it has an inherent energy benefit. And we're looking at combined audits now for water and energy. You know, if we're going to go into a house, let's go and do complex fluorescence, energy insulation, and water efficiency at the same time. Let's treat it as one comprehensive package. Let's do the same in industry. If you've got, you know, a plant manager that's willing to let you in the door for energy, let's make sure we're there with the water issues as well. And then the new emerging technologies that are being developed, the new commercial dishwashers, pre-rinse spray valves that are getting more and more efficient, all of those technologies will have those resulting energy benefits, and we just need to be smart about calculating what those are. So, okay, so I talked about California. What does this mean for the rest of us out in the rest of the United States? What's happening out there? Well, there's a lot of work that's occurring in many different unrelated to you venues. I mean, when the River Network gets a grant to study the water and energy connection and is going to be doing meaningful work in pilot cities around the United States, you know it's bigger than just the water utility community or just the water efficient technology community. And now that statistics are being gathered up nationwide about what water and wastewater energy use is, you know, there's starting to be some pretty interesting numbers. About 75 billion kilowatt hours per year go into water and wastewater plant energy use. That's the estimate. That's the most recent. It's still pretty old, but it's an estimate that we need to refine, because again, I would submit that that's probably underestimating the true value of that water. 3% of U.S. total energy consumption. That was an EPRI estimate, you know, about 8 years ago, 5 to 8 years ago, and Administrator Johnson said 4%. I submit that once we finally do the research, we'll find that the number's a whole lot higher. And in terms of the bill, it's already costing us $4 billion a year and increasing for, you know, these infrastructure plants, for building new capacity, for maintaining them, for basically reconstructing them when they're, you know, exceeding their useful life. Those are all bills that we as taxpayers as well as ratepayers have to pay. And in this particular energy analysis, we have to look at the whole chain. It's not just that treatment process that we were just showing you on that slide. It's the amount of groundwater pumping we're doing. It's the amount of interbasin transfers that we're doing. It's the pumping actually to the house. We forget that, you know, utilities have different pressure zones and have to pump various amounts depending upon, you know, the elevations in the service area to make sure that the pressure is uniform when it's delivered to the consumer. Heating and cooling water in industries as well as households, pumping water to the sewage treatment plants and discharge points, and then hot water heating, which is a very big issue and one which now Gary has devoted his life to.